when meteors come into the atmosphere, and like I said, usually you have meteors, you think of them as big pieces of rock that come in and you see the big fireball in the sky and it's a shooting star. And when meteors come into the atmosphere, well, there's actually many small ones as well. They're just basically little pieces of sand, and there's a lot more of those than the ones that you see. And those come into the atmosphere, and when they come in, they're coming in so fast, about 75 kilometers per second is the upper bound, so very fast. And it heats up and it rips the atoms apart, and it leaves behind a trail that we can see with radar. And that trail then moves with the winds. So we can use the meteor kind of as a marker in the fluid of the winds and then use that to kind of map out the wind patterns. One big effect that we see is gravitational waves. It's kind of like tidal waves, when the tides change as the Earth rotates. Well, that also happens with the atmosphere. And those waves have play a big part in the energy balance for the atmosphere and for the ionosphere and for the different parts of our atmosphere. That would affect their everyday lives. We depend on the sun for all of our energy, right? And we also depend on how the atmosphere gets heated and how the atmosphere loses heat as well. And everything, all of our energy comes from the sun. So this is a really important process in understanding part of that energy balance. Most of our weather is down in the troposphere. And this is about 100 kilometers off the surface of the Earth. So it doesn't directly affect our weather, but atmospheres, everything's connected, and especially with the energy, you have transport through these layers, and it's all connected, and that's part of the difficulty of getting good models and getting it all sorted out. So not directly like some of the processes, but yeah, the energy balance is really important. I don't remember where it was, but I learned about like NASA and how they put things in space, and I thought that was like the coolest thing I'd ever seen. So I knew I wanted to build things like that, and all the way through I knew I wanted to build things that went into space, and that got me interested in engineering and got me interested in science. And with the remote sensing, which is kind of what radar is, we can sense things without touching them, without going out and actually measuring the things. We don't go up into the upper atmosphere to measure these winds. We remotely sense it, and that's really interesting to me because you can detect things and you can see things that you would never be able to touch, and you'd never be able to actually go there and do it. Kind of the combination of building things that go into space, and then also the radar and the remote sensing is really what interests me. I think persistence is the big thing. So just wanting to know what goes on. And a lot of people will say that, well, you need to be good at math and you need to be good at have an analytic mind. And certainly that's part of it. But if you just have that desire to know what's going on, I mean, you'll build that analytic mind and you'll build those math skills as the tools. It's more just the desire to want to know what's going on and kind of the persistence to follow it through. And that was my big thing. And I think it was in third grade I was told, well, you're not going to be good at math, and I was doing terrible in math and science, and I'm like, well, I want to learn these things, and I wanted to learn how things work, and I wanted to build things, and I wanted to build spacecraft. So I just kept at it, and here we are. So a persistent mind, and really having the courage to follow what you want to do, and not listen to people telling you that you can't do it. I think that's by far the most important thing.